So once you've got privileges on a server, there's stuff to find in there. You might find passwords stored stupidly someplace or other. Some people just stick passwords in Word documents. Other people stick them in the proprietary store of software. So there's a lot of interpreter modules. You can search for files that just have the name, password in the name. That'll get some of them. You can turn on keyloggers and record key presses. You can turn on the smart locker script to lock the user out and pop up a box saying they have to put in their password to unlock it, to trick them into typing their password to catch with the keylogger. And you can migrate to Winlogin, which is one place you can go to a process that will not be closed quickly by the user, so you have longer ownership of the box. And there's a lot of credential gathering scripts in Metasploit for all different situations, like steal it from FileZilla and steal it from other products like Skype. In my experience, a lot of these scripts stop working because people write them and then they don't maintain them, and after a few years they update the software. But anyway, some of them work. WinSCP is a product I use to replace the OpenSSH client that we used on campus. We used something called but it's SSH Secure Shell we've been using for years on campus, but it hasn't been updated since 2003, so it doesn't work anymore because of Snowden, everyone has updated from TLS 1.0 to 1.2 or 1.3 now, and it won't accept those old certificates. So anyway, I use this instead on Windows machines, WinSCP. It's an updated product, but if you save the passwords, it saves them in a lousy way. It's just an MD5 hash, and you can steal them here, and they're pretty easy to crack. So they have updated their HTTPS protocol, so it talks to modern servers, but they have not updated their internal storage system, which would have been a logical thing to do. But I think most people have the attitude that if you cared about security, you wouldn't be storing your password in some random app. I don't know. Anyway, you certainly shouldn't. Many apps will offer to remember your password, and if they do, you should of course be aware that they're probably doing something horrible with your password, like storing it in plain text or something. And by the way, they kind of have to, because it can't hash your password in a good way because it has to log in for you. So it has to be able to actually recover your password. So it really can't use anything other than reversible encryption or very weak hashing. It's kind of impossible. Anyway, if you want to avoid this nonsense, what you ought to do is use certificates for your SSH login. All right, so you can steal these passwords right out of there with Metasploit, the WinSCP, and there's a thing called Credential Collector that will harvest a variety of credentials it finds and store them in the database. Remember, when you start Metasploit, it will ask if you have a PostgreSQL database running, because it wants to have a database to store all the loot in. You can run it without that, and then you just see things appear on the screen, but if you're running a database, then it's storing it all in a searchable database for later, which is certainly what you want to do if you're scanning a large network. And so here it is, gathering credentials, collecting a lot of tokens. It's got some Windows password hashes, it's got some tokens, and so on. It goes through the system and steals what it can find. All right. There's group policy preference saved passwords. This will go to XML files containing user accounts and passwords and attempt to decrypt them using Microsoft's public AES key. So I don't know how often you're going to find these files. I've not used this one. There is a project where you set up a domain controller and start stealing things, and I didn't try this one. I kind of doubt that Microsoft would really store reversibly encrypted things with a known AES key very often. I would like to hope this is an old version. I don't know. McAfee virus is well known for not storing your password correctly. There was a vulnerability about 3 years ago where McAfee Enterprise stored the domain administrator password in a XML file on every machine. So I don't know. Hopefully they've also updated. This at least is some kind of hash, but they say it's a hash and you can crack it with John the Ripper. And it has a salt, but the salt is always the same and they know what it is, so that's not really doing any good. Outlook, of course, Microsoft saves passwords also, and just like all these, your Outlook has to log into your SMTP or the SMTP server. Now, in the old version, used until about 5 years ago by most people, it logged in with plain text. So every email client sent your password in plain text every 5 minutes over the network. You can just pick it up at Wireshark. Starting because of Gmail did it first, And all the other email services were sort of humiliated into it about 5 years ago to moving to encrypted SMTP logins on port 465. And now they do that, but the client still has to have your password to set it up. So it has the same problem I was saying earlier about WinSCP. It can't do its job without having access to your plaintext password. So when you save your password in there, it's got to be reversibly encrypted. And that just means it's only a matter of time before people reverse engineer that encryption and get in. And Skype, of course, Skype has had a lot of security problems. Again, they're saving a password, and in principle, Skype, you're only logging into a Skype server. So if they had asked me what to do, I would have said, store something that can't be reversed, like use public key encryption. Encrypt something on the machine. When you type in your password, encrypt it with a public key and store that. And nobody can decrypt it except the private key that's on the Skype server. Now that would be secure, but I don't think that's what they're doing. They can find login credentials on here. What most people seem to do is probably just to make their job simpler, they make it so that your stored credentials are just typed in like you typed them. And it has to have access to your plaintext password. So 2 SHA-1 hashes of salt data. Anyway. All right. And then there's Net is the Windows command line tool to connect to shares and also to control user accounts. So Net users will show all local users. Net local group administrators will show all local administrative users. And there's a Net users command that will show you all the domain users. We found it, we were looking for it before the last CCDC. PS will show you your processes. And this will also show you UDP listeners. PS and Netstat will find them. You cannot detect UDP listeners very well with Nmap because UDP has no handshake. So if you send a packet of some sort to a UDP port, even if it's open, you typically get no answer. The only thing that will get an answer is to send a properly formatted request to whatever service it is. So if it's something like DNS on port 53, Nmap can do it. But if it's on an unexpected port or an unusual service, it doesn't know what to send and it cannot detect the service. Bash history is good, clean fun. This was a big deal at CPTC last time. They had a lot of problems setting up the network. So they were up late the night before the contest setting up the network. So the last thing they did was run a script, and the script had the administrator password in the commands, and they forgot to delete the bash history. So the students connected, checked the bash history, and the master password was just right there. They got over everything. And they said, as we thought, at the end, they said, we didn't mean to leave that there, but that's true of all bugs. I mean, and so this is one thing to do when you do get an account on a server, is just check the history, because a lot of people do type passwords and commands. And if you go to Stack Exchange or other websites, you'll often find people saying, you can do it this way, but you should do it this other way, so you avoid putting your password in the command line for exactly this reason, because anything you put in the command line is stored in plain text logs and all over the place. And real high-tech professional Linux system administrators learn to use versions of commands that never put the password in a command. They refer to a file or a certificate or something so that the history does not include passwords. All right. Then there's lateral movement. As I mentioned before, you take over one machine, you can see like the web server, and now you want to move to another machine. Typically, when you get into a domain, the first thing you do is get some workstation to run malware. So now you're on a random domain member. Now you want to get to local administrator and steal the hashes and try to find a domain administrator account, which should not exist, but it does in practice very often exist because domain administrators log in with domain administrator credentials on end workstations, which is a unsanitary practice, but very common. All right, and if you have non-domain computers, very often the way they are deployed is with image deployment, so they all have the same administrator password. So if you just find one, you've got them all. This is increasingly common because so many people deploy everything with images. And I was impressed with that Amazon talk from that visitor a couple weeks ago, where he said, if you log in with SSH and type any commands on an Amazon machine, you're wrong. You should never do that. You should have an image that boots up and automatically runs everything you need. And if you want to change it, you make a new image and push it out. Because the whole point of Amazon is you have one server, and when you have more traffic, you make 5, 10, and 1,000 servers all identical. That's a shared load, so you shouldn't be doing anything custom to one machine. You should just be pushing out an image that automatically does everything you need. Anyway, psexec is the sysinternals tool from Mark Russinovich from Sysint, and now part of Microsoft. This is a tool that will request a process to run on another machine. Now you are supposed to have credentials, administrator credentials, that it will now connect using remote procedure call start to service and start a named pipe to control it. It is a feature of Windows and necessary for file shares and for domain controllers to be used that you have this ability to run a process on another machine. It's of course just what we love, run a process on another machine. It's even more fun than tricking them into running malware. So it's an opportunity, and all you need is credentials that give access to the admin share, and you can push software up and run it with this thing. And you can use hashes instead of passwords. This is the pass the hash attack, where you don't bother to crack the hash, you just use the hash as authentication, and Microsoft Windows domains will accept it. People have been wondering why for years, and Microsoft gets real mad and says there's no alternative and everything else is just as dumb, and they never change it really. But they have, in the recent versions of Windows, made it more difficult to seal the hash. That's their response. So here's from your books, you set the user to this and set the password to the real password, and then exploit. So this uses psexec to run a process on another machine with a real password. So that's reasonable, but you can just use a hash. First, now one thing you could do is run hash dump to get the hash, or any variety of scripts that will try various techniques to dump the hash off a Windows machine. And once you've got it, you just put the hash in instead of the password and run the same module, and it just sends it as if it was a password over the network, and domain controllers will take it. This doesn't seem necessary to me, but Microsoft seems to have a fixation that this must be done this way, even though people have been humiliating them all the way since the Cult of the Dead Cow and Loft Heavy Industries made the first tool that used this, and we've all been using it for 20 years now. So Microsoft finally got humiliated enough to pretend they stopped it and put up a web page saying they'd stopped it. Within a few days they had to modify their website to say it's now a little more resistant to it, because everyone laughed at them because they haven't really stopped it. It still uses your hash. What they've done is they've made it possible to create an account called a siloed account, which cannot be used on end workstations, can only be used on the domain controller. So that hopefully you will not leave a high privileged hash on the workstation. That's the big step forward. Anyway, that's the game. Like I said, at first they said they fixed it, and then they said they improved it, because they got humiliated. This is like, you remember Apple used to have for like 5 reasons to buy a Mac, and number 1 was no viruses, and then they had to like take that bullet off when they created a virus problem by blocking a PDF update for 6 weeks. This is the stupidest thing you could do, is not update, and Apple compelled you to not update by blocking the update, and this is what's wrong with Android. Nobody updates, so using software and not updating it is just a kick me sign. And Microsoft figured that out, and the other companies like Google are just way behind at catching up with Microsoft security measures. So the pass the hash attack can still be used, but it's getting more complicated on the very latest version of Windows if you implement all the newest features, which almost nobody has yet. If you want to do the same thing in the Linux world, you can use SSHExec instead of psexec, and that will let you remotely run a process on another Linux machine the same way. In this case, you really need the password. You cannot use pass the hash in Linux, as far as I know. All right. And so it looks very much the same. You use SSHExec, so off you go with the username and password, and you can run any payload you want on the other machine. All right. All right, so there they have a payload of reverse TCP and then exploit it, and you get a shell. All right, 5 questions. So which interpreter command improves your persistence? Okay, that's migrate. You can migrate to a process that lasts longer. Okay, which utility weakly encrypts your passwords? All right, WinSCP, good. All right, what command will show you all the users on a Windows system? Okay, net users, good. All right, What file may expose plain text credentials on Linux? Okay, bash history, good. All right. And what command runs a program on a remote Windows system? Okay, psexec, good. Okay, so here are the winners. So Windows tokens. These are data structures stored in memory, and they keep track of who owns a process. So if you start a process, remember you see processes by you, processes owned by the administrator, or owned by a system, and these tokens are just sitting in memory recording that information. And you can just copy the token from one process and put it on another process. You can see the tokens in Process Hacker. It will show them to you. Here's tokens. This is the administrator token. And here's the information, debug privileges, just a series of privileges you might have. Because each token has different privileges. And there's quite a few complicated privileges in Windows. And they're all stored in this token in a data structure. You can see it in Process Explorer 2. Just looks very similar. There's a security tab that shows you the name of this, the group they're in, and here's who I am. I'm this SID, the administrator. I'm in these groups, and I have these privileges: backup, change notify, global, and so on. Many little elemental activities, and it determines whether I can do them or not with that token. So it amounts to like a cookie on a web page. It just identifies who you are and what you're allowed to do. And there are delegation tokens, which are people logged in locally by remote desktop, and there are impersonation tokens, which are done for non-interactive sessions, things that are running in the background like a process or logon script that are not interactive. And so tokens persist until a reboot, and when you log off, it does not invalidate the old tokens. This is also true of cookies on most websites, and I made a big deal about this a couple DEF CONs ago when I heard about it. It's true of Microsoft Office 365. About half the services, when you log in, give you a cookie, and they never invalidate that cookie. So if I steal the cookie, I can reuse it to get in your account. And even when you change your password, I can still use the old cookie because they never invalidate them. So it's pretty rude. So anyway, Incognito steals and manipulates cookies. So if you have an interpreter session, you use Incognito, and now you can impersonate a token, list token, and so on. And so if you list token, you'll see the tokens available on the system. And here it shows there are processes running with system tokens on them. There are processes running with administrator tokens on them. And you can just move to either one of them. This one here has 4 delegation tokens available. So it's pretty awesome. All right. And this, I know if you did the domain controller projects, this was how I set it up. So you could become domain administrator, not by stealing the domain administrator's hash, but by stealing a token for a process that the domain administrator left running on that machine with administrator privileges, which is something that can happen because they do something like push out some script and it executes on every machine with their privileges. And if it's still there, the token is still there and people can ride that session to get in. So here, I impersonate a token and now I can execute a command with that token. So I execute CMD and now I leave a interpreter shell and I get a command shell and now I'm the administrator. I'm whoever token I imitated. So it's pretty awesome. And this way you don't mess around with passwords or hashes at all. You just cut right past that. All right, and then there's available tokens. That particular box only had 1 or 2 tokens available, but on other servers that are used by many users, there will be many tokens available on the machine. Now another thing is SMB capture, and this is what Loftcrack, their original software, did. Microsoft has to pass credentials over the network to log into file shares, and they have been through several generations of trying to improve what they send over the network. The original ones sent LM hashes over the network, and you could just crack them and get the password easily, and that's what the original Loftcrack tool did. They've done other things to make it a little harder, but it's still not as hard as it needs to be. So one thing you can do is run a malicious SMB server, and then wait for people to connect to you, and they'll just send you tokens. So Microsoft Metasploit has an SMB capture module that will run a malicious server, and then if you can trick people into trying to visit this server, it'll send up their tokens, which you could do with, say, a link on a web page. There's a tool included in Kali called Responder, and Responder is a tool that not only runs a malicious server sharing files, it then puts itself in the middle with poisoning to trick you into visiting that server even if you didn't want to. So anybody pretty much on the network, they say they start the responder and wait a while, and it will just gather more and more credentials as time goes on. Let it go for like an hour and you'll get all kinds of credentials from all through the network. And so here's how it looks when it runs. You have a responder, it's running a bunch of poisoners, running a bunch of servers. So it's all these things are running, hoping someone will connect, and when they connect you will get some kind of token for them, some kind of network login, like a Kerberos login or an NTLM hash, and you try to accumulate all the ones you can get. And after a while you'll see them. Here's somebody's SSP hash, and there will be more things appearing there, so you'll gradually get more and more. And you hope to be able to crack these or pass them and get in places. So you get some stolen hashes, and here she shows a bunch of hashes that were stolen through the Kali SMB server. All right. Now, Microsoft originally used LM hashes over the network, which was terrible, so they upgraded to NTLM hashes, and after this grabbing hashes off the network attack humiliated them enough, they made NTLM v2, which is not used to store local password hashes. I remember I gave a talk at Microsoft about this, and the guy in the audience was mad at me saying I was misrepresenting their security because he thought they had something called NTLM v2, and they do, but they don't use it. They never upgraded the storage on the disk. All NTLM v2 is used for is sending the passwords over the network, and it adds another layer of encryption to the hash. So it's hashed and then encrypted and then sent over the web, so it makes it slower to brute force. It has an HMAC and a challenge, which we're talking about in the cryptography class, but it's more difficult to crack than it used to be. Not impossible for short passwords, but still stronger than it used to be. So anyway, this process is called pivoting, where you're attacking a machine, you take over some end user station like Windows 7, and now you want to take over some other machine here, and you can't get in there directly, so you try to pivot through this machine to get there. This is what you should have in a properly segmented network. You should have your routers access control lists set up, and your VLANs and your routing tables set up so people cannot directly connect to your high value systems. They can only connect to things in the VMZ, and then they have to pass through more layers of security tests to get to the high value stuff, because you have certain public things like your web server and your email server, but you shouldn't put anything very valuable on those because those are at high risk of getting hacked. Those should be on other servers that are protected and not directly connected to the internet. That's the right way to set up a network, and many people are smart enough to do this. So you can take over the first machine and then use route add to add a routing to the routing table. And a normal routing table has the name of an interface or the name of a gateway to send packets to, but this says traffic in this network goes to that number, and that number is a session number, a Meterpreter session number. So you route traffic through that Meterpreter session to go to the other end, which is like a VPN, and essentially that's what's happening here. So that's pretty cool. It of course only works for traffic generated by Metasploit because that's not a real routing table run by the operating system routing real traffic. But it does mean that your Metasploit attacks will now go into the network through the compromised system. In the old days, before Metasploit, you would have to take over the system and then install a tool like fpipe that would take commands on one port and pass them to something else. You'd have to put in some kind of relay tool. Now Meterpreter does that automatically for you with this route command. So now you can, if you want to do port scan, you can't run Nmap through, but you can use the port scanner inside Metasploit to scan through there. And this is what you do if you do the domain controller projects down around X12 or X13, those ones down there. All right, so you can run it, and then you can run any exploit through here. So here she's running MSO867 on the host, and what's great is you don't have to do anything. You just give it an IP address. If the IP address is in that range, it'll automatically go through your exploited system and pivot on the way there, which is very nice. All right. You can make a SOX proxy. SOX proxies are really old technology. The only service that uses them much anymore is Tor. And the point of a SOX proxy is to be a session level proxy, which I think is layer 5, right? Please do not throw sausage. Maybe layer 6. No, 5. All right. And the point of that is it can take all traffic on all ports and move them to another server. And that's what Tor uses, because they want all your traffic to go through another server so people cannot tell your physical location anymore. And you can do this in Metasploit also, but you're going to have a client and run a server. And then what happens is your client IP addresses are hidden. All the connections are made from the server, and you view them from the server without your IP address making it to the other end. That's why Tor does it. So that's the point. Any protocol, any port, all goes through this proxy if you set it up correctly. There are different versions of it. In Metasploit, they use SOX4A, and this uses the tool called Proxychains, which is a common Linux product used to set up these proxies. So you listen on a address, and typically it's 1080. You can move the port, and then you connect to that proxy, and you can funnel all your traffic through it. And if you do this, you can now run any tool through the proxy, like Nmap or anything you want. You're not restricted to just Metasploit, because this runs all the traffic on the box through a proxy. So that's the game. By default, it will connect to Tor. That's what most people want to do, is just hide their location, but you can change a file to point it to the Metasploit listener, and now you will be SOX proxying all your traffic through a Metasploit session. So now you can run any hacking tool you want to the box. And so here's Nmap going through Proxychains. Use Proxychains, then Nmap, and then the rest of the Nmap commands. And it will go from the Proxychains configuration file, it will know where to connect, and that'll go through an interpreter session, and you can now run Nmap on somebody's network when you don't have any ability to send direct traffic to that box at all. You go through your pivot, which is pretty awesome. All right, and then we talked a little about persistence. There's a little more to do, of course. Your Metasploit session typically never writes to the hard disk. It's running in RAM. It's typically injected into a running process, and usually by Dell injection. So if that process halts, then you lose connection to the box. So typically you want to migrate to another process so you don't have to re-exploit the box, because typically you had to use something like social engineering to exploit the box, and you can't just keep doing that over and over, or no matter how dumb they are, they'll wise up. So there's a lot of ways to get persistence. Persistence just means you can come back tomorrow and still own the box. One thing you could do is add another user, so it has SSH or RDP session. That would be pretty awesome. Then you can come back the normal way. You could create a domain account. You can use add user to add yourself to the sudoers group, so you can come back later. Then you don't maintain any constant network connection to the box, but it gives you a backdoor so you can get back in later. Or you can run a persistence script. A good enough script will let you survive a log off and even a reboot. There's a whole bunch of tools. There's a persistence tool in Metasploit that will put some Trojan on the machine and will automatically connect back to you on every login and every reboot. Of course, that means it's got to write something to the disk, and antivirus might catch you. So that's the point. It puts an agent on the disk. This one here uses a VBasic script, VB script, in the temp folder, and then a registry entity to run it. So each of those activities are things where you might get caught. In particular, writing the malware to the temp directory, it's almost certainly going to get caught by antivirus. So that's why you'd want to hide it with something like Veil Evasion, or better, with a custom scrambling tool you wrote yourself, which wouldn't have to be terribly clever, because the antivirus can only detect known scramblers. All right, you can also use a cron job. This is my favorite way of automating things. It's a very old way of automating things on Linux and Unix. The boot up sequence has a whole bunch of different things that start at different times, and there's various different versions of it, System 5, and then there's something else. And the real Unix experts know all that, and the slobs like me that can't be bothered just learn cron, because cron has been there for decades. And it doesn't let you exactly start things at startup. It lets you start them every minute, or every 5 minutes, or every 10 minutes, or things like that. But starting it every minute, or for every 5 minutes is okay, because that'll start within 5 minutes of boot up. So you specified here, this will start every 10 minutes, and it'll run this script, and this you may recognize as reverse shell. This will netcat to the server on that port, and then shed bin.bash, so it will phone home and give that guy command shell. Of course, this is a kind of artificial example, because most people don't have netcat on production servers. They shouldn't. And if they do have netcat, they should have the safe version of netcat, which doesn't let you do this. The NC-E will actually even warn you when you compile it, this is the unsafe version of netcat, you really shouldn't be using this. Kali has it, of course, but only your very dumb people would have that on a production box. So here's a better cron, here's another cron script, which I like better. This is the one I use on a lot of my servers. that doesn't just do it every 5 minutes. It checks to see if the process is out there. You can do pgrep nocd, and that will return 1 if there is a process already running, and only if there's not a process running, then do this. This is a friendlier way to do it. And the no hup means it will take the output of this command and put it in a file that's going to be thrown away, and the ampersand means it will run in the background and not stop at this point. So that's a way to start a process only if it's not already running, which is a little bit friendlier. All right, the last cahoots. 4 questions. So what data structure identifies the owner of a process? Okay, that's a token, good. All right, what Kali utility collects password hashes from the network? That's responder, good clean fun. All right, what interpreter command sends all Metasploit traffic through the exploited system? That's route, okay, good. And what Linux utility starts processes automatically? All right, that's cron. In Windows, it's called scheduled tasks. Does the same thing. So, Stan and BBB and Groot. Well, good. That's it. I'm going to go up to the lab if anybody wants to work on projects, and that's all I'll do next week. I recommend this Tuesday event highly. Tuesday at 6:30. Go to this thing if you need a job. It's a very good opportunity.